Hello, everyone. Thank you for joining today's session, and I will be the moderator for this afternoon. Um, Today, before we join in, I would like to cover some housekeeping items. This session is recorded, and we will be sharing the recording after the event, as well as any presentation material. Um, we would like to encourage you to ask questions throughout the webinar. You can do so by typing them into the QA chat, as well as we have a dedicated segment for Q&A at the end of the presentation. Before we begin, our topic today is business potential of AI agents using multi-agent conversation framework, and it is going to be delivered by Asif Hussain. So over to you, Asif. Thank you.
Hi, Sakina. Welcome everyone for this session today. So we will quickly
Asif, I think you're on mute.
Sorry about that. All right, so we will quickly jump towards the webinar. And before coming towards that, this is me. I am practice head for AI in automation at Royal Cyber. I have a background with software development on multiple tools. For past few years, I've been working dedicatedly on work productivity enhancement tools using automations, robotic process automation, and now LLMs. That includes agents. All right, so what is an AI agent? Let's move towards that quickly. So an AI agent is a software program that uses artificial intelligence to interact with its environment and perform tasks. So AI agents can collect data, analyze it, and use it to make decisions and achieve goals by performing tasks. So it can plan, it can reason, and it can act. So now let's talk about how AI is transforming business. AI isn't just about automation. It's about making smarter decisions, optimizing costs, and enhancing customer experiences. Let's break it down into key benefits of it. So it gives enhanced efficiency and productivity. It can automate repetitive tasks, streamline workflows, and enables teams to focus on strategic work so they can get more output by less efforts. It can help in cost saving by reducing the operational costs, by optimizing resources, predicting demand, minimizing errors, leading to smarter spending and higher profits. It can also help in improved customer experience. So by virtual assistants or chatbots, personalized recommendations, creating seamless interactions, boosting customer satisfaction is possible. It can help in data enhancement and analysis. It can help in competitive advantage by adapting faster, innovating better, and staying ahead of competition. These are some of the stats indicating future of AI in customer experience. So you can see by 2030, 70% of companies will adapt AI in one or other forms. And some of these stats are just for this year. So by the end of this year, you can see the expectation of reaching 2.5 billion industry in USD. 95% of customers interact um, with AI now. All right, so we already saw in the first slide that what is the definition of AI agent. Here you can see some schematic of how it works. So agent has some sensors. It can uh, understand the environment. It can take actions in the environment to get things done for you. So it has reasoning ability. It can understand the context, and it can get things done for you. So the future of AI is agentic, and AI systems are evolving from having conversations to getting things done. This is where we expect much of AI's value to shine. It's the difference between generative AI recommending diner options to agentic assistants that can autonomously place orders for you and arrange delivery methods. It's the shift from summarizing research papers to actively searching for and organizing relevant studies in comprehensive literature review. So these are some points like why multi-agent systems matter. They can help in solving complex problems, scalability and efficiency, resilience and fault tolerance, improve decision-making, real-time coordination, and simulation and training. And these are just a few areas where they can help. We'll see like how they are developed or what some of the frameworks through which you can develop such multi-agent solutions. So we see promising um, quotes from prominent technology folks about the power of agents and how agents are going to take over the way business is performed. It is said that it is kind of a thing that changed or revolutionized industry with the invention of electricity or with the invention of computers in the beginning or with the invention of um, internet when we saw every organization started to have websites. Now it's an era where every organization will start to have agents to get things done for themselves. There are quite a few multi-agent frameworks available in the market. Two of them are listed here, CrewAI and LangGraph. Both are free to use open source frameworks, and you can experiment with them. So LangGraph and CrewAI. So if I talk about LangGraph, it is built on LangChain, and LangGraph focuses on graph-based agent orchestration, allowing for flexible, complex workflows where agents can communicate in dynamic branching conversations. So it enables creation of cyclic or multi-step workflows. So when we give a problem to a multi-agent problem solver, they were the agents within that multi-agent solution work as a team, and each has some expertise. So each of the agent is specially designed to take care of certain type of task or certain type of operation. So when they work in collaboration, they work together to build something or provide an answer or provide a solution that is better than assigning a job to a single agent or assigning a job to a single human being. it works like a team. It works like a team of human beings, each having a different type of expertise. When I talk about CrewAI takes an agent team approach where different agents act like crew members with specific roles, collaborating in more structured and task-oriented manner. So how it is different from LangGraph? Um, LangGraph has dynamic branching conversation, while the CrewAI is more task-oriented and structured with sequential and role-based paradigm. But as the agenda of today's webinar is written, we will be diving deeper into Autogen, that's Microsoft's framework, also available open source. So here's what Autogen open source framework building AI agent look like. It is so this framework enables AI agents to act autonomously and communicate with each other to solve complex tasks with minimal human intervention. And you can even uh, you have an option to keep human intervention or not have human intervention in between. It can help you automating workflows to optimizing decision making. Autogen actually unlocks a new level of AI driven efficiency. So as AI becomes more agentic, it doesn't just assist you, it works alongside us, transforming how we interact with technology. So Autogen offers a unified multi-agent conversation framework as a high-level abstraction of using foundation models. Foundation models, if as you know, are the LLMs available in the market. So it uses them, and it has features capable of customizable and conversable agents that integrate with LLM tools. And we can keep a human in the loop to see the interactions or to respond to or provide feedback to the interactions different agents are having in between. So in a multi-agent conversation, you have several different agents, and each of these could be a specialized model, could be using a specific model or specific expertise they have to solve a certain type of problem. So interacting with one another, each agent has a specific function or knowledge area and may handle part of a conversation or part of the problem solving. For example, one agent might be responsible for understanding user queries, while another could generate responses or handle specific tasks such as generating code or going to a browser to get things on a website, external website, or pick information, extract information from an external website, or expert of writing maybe SQL queries to query from that query database as per the instruction. There can be coordination between the agents, and the agents coordinate with each other to ensure that the conversation progress logically. This can involve passing information back and forth, adjusting responses, and even determining when one agent should defer to another. And it has a capability of understanding if the conversation is not going in the right direction in order to resolve or in order to get the overall objective. It can try to moderate and bring it back towards the objection, the uh, purpose of or the goal of the overall execution. has a functionality of task decomposition. So in a multi-agent conversation, tasks are often broken down into smaller components that individual agents handle. For example, if the goal is to answer a complex question, one agent might gather information while another might process that information and present it in a coherent response. So here on this slide, you can see an illustration of the structure of conversable agent with three different agent types. One is the assistant agent, right? And this, let me take something to highlight. So this one, right? It uses OpenAI's model to assist users, and you can use human input mod like this, where I'm writing always here. I can write never also as an input. And based on this parameter, the multi-agent system understands that whether it needs to get feedback from the human user or not on each step or each step of conversation between the agents. We have here a user proxy agent, this one. It represents a user's interaction with the system. So human input, if it is kept always, this agent will be responsible for getting the user input. So it acts as an intermediary between human and AI agents. Next, you can see group chat manager. It manages multiple agents in a group chat setup. So it can coordinate multiple agents, and it can be the moderator of the information getting passed between the agents. We will see an example in the subsequent section. Yeah, here. So you can see a simple example that we will make here today. It will have actually two agents working for us, and one agent we will call it as assistant, and the other will be the user. The user agent is a coder, expert in writing code in Python. And the user agent is expert of understanding the requirement and in natural language and trying dividing it into segments or chunks to get things done. So I'll stop the presentation here to take you to development environment. All right. So first of all, if you want to follow this while I'm doing it, you can do it, but you will have to install application for that, and you will have to install PyCharm for this purpose. So PyCharm, I can show you. If you search PyCharm Community Edition on Google, you will get to this page. The first thing, even then, it will show the professional edition on this page. We don't have to have it. We can use the free version of Community Edition. Just download this, or you can change your OS if you have you're accessing it from some other, and download the version that you need for the community edition and install it. Once you have PyCharm installed, you will see it something like that. And the first time you open it, it will ask project name. So you can just give it anything. I just gave Autogen Beginner 1. I have done some work. Ignore that. You will not see this. You will just see an empty folder once you install this. All right. One more prerequisite that we will need, we'll have to install the Autogen library, Python library. So in order to do that, click here on terminal once you have the PyCharm installed and write this. Oh, sorry. Right. We'll have to write this and press enter. I am not pressing enter because I have already done this. So once you do this, it will take a short while. It will download the library and install it with your Python. Once you have done that, you are all set to develop using Autogen. Autogen, that is a multi-agent framework. All right, so I'll create a new directory. I'll name it something, let's say coding assistant. This is here. And then I will create a Python file, name it main.py. And start writing my code. So it's okay if you cannot follow it right away. You will have the recording. You can follow it later if you want to. All right, so we will import Autogen first. It's handy if you have some idea about programming in Python. If not, it's a fairly simple language to learn. Uh, and in order to test it, you can just do whatever I'm writing. All right, so first thing I'm doing, I'm importing Autogen library, and then I'll define a function named main, and I will do something. Let me show you. I'll use the library I just imported and call a function from it, config list from JSON. All right, so in order to use Autogen, I'll need access to ChatGPT. So to access ChatGPT, programmatically, I need to have key to use, and I'll have to store that key in a JSON file. So I'm just providing name of that file. You can name it anything. Right? We haven't so far made this file, so we'll also have to make this file. I can code the remaining part later. Let's make this file first. So we want to make a file with the same name that we just typed in our is AI config list a OAI config list JSON, right? It's the same name. So what I'll do here, I'll write a JSON file. We need to specify the model of ChatGPT we want to use. I will name it, provide a specific name that I want to use. That's GPT 3.5 Turbo. And I'll have to provide the API. So saving it here, I'm not typing the API key right now, and I will type it here or copy paste it here just in a while not sharing my screen. So I'll do it later. Coming back to the main method or main function I was writing, we specified that what JSON file to use OpenAI or ChatGPT. And now what I will do, I will define the agent. So I will make two agents as we saw in the PowerPoint slide. Yeah. All right. Assistant agent name is assistant. Right. So this is the definition of our first agent that will just receive the requirement that a human user will provide, that what we want this multi-model agentic framework to work on. Now the second thing we will make user proxy. This is how we are naming the second agent. Autogen dot proxy agent. Name user human input mod. That's what we were discussing on the slide. I will say it never here. I can put it always also, but I want it to work independently. I don't want to provide feedback on each step. So execution config. So since I will be giving it task to code something for me, so it I'll have to specify where it will save the coding. It will code it and save the files in work directory named coding. Okay, and we can use Docker to host that thingy that we will develop, but I don't want to do it right now in order to make it simple. So we said we will not use Docker. These are the two agents that I developed. Now, what task we want it to do? Can specify a task and to which agent we want the task assigned. We are assigning to assistant, the first agent we developed, this one. Okay, so the task is, you can write anything. I will write an example, plot a chart of Meta and Tesla stock price changes. Okay, so I want a graph I want a program that is capable of pulling prices, change of prices in Meta and Tesla stock, and plot a graph. So this is the end of my definition for math function main. I'll just call this function. All right, so I think the code is pretty much ready, except for one thing. Okay, one thing is, okay, I haven't specified the variable that it is actually definition of message. Okay, so remember we made another file that was this one, and we haven't specified the API key here for ChatGPT. I will take a second, take it to my other screen, copy my key, and get back here. So you can see that I copy pasted my key here. I will have to save it, Control S. I saved this one also, Control S. All right, so coding assistant is the folder we created. There are only two files in it. You can see one has the API key, the other has the code of two agents, and I specified a task here that what I wanted these agents to do. Plot a chart of Meta and Tesla stock price changes. Now let's run this. Keep an eye here on the terminal section. The graph came up on my other screen. Let me try to get it here. So this is the graph. It not only produced code, it ran the code, and the graph is also generated. In this, look at this, how the agents performed. So this is how the Python code that I wrote. Okay, sorry, it actually ran from a previous execution. I mean, I will have to specify this one. Anyway, the same code was there written earlier also by me. So you can see the results from there. This is why the chain folder name is different here. And this is where it actually produced the code. And you can see some Python files generated. So what it did, the assistant got the instruction to plot what I asked for. So it understood the task, and it said that we need historical stock price data for both companies. Let's start by downloading the historical stock price data for both this and this. So it understood the task, it understood what steps it needs to do, and then went ahead. Could you please confirm if you would like to search for suitable sources within the historical? So both the agents are collaborating and talking to each other. And in the end, look at this, it even installed this library because this was required in order to do that. So it installed Y Finance library. It came up with a solution which needed this library. So it installed this library also. Look at the steps while it is installing it. So it is getting things done for you. And then it moved ahead. It did these steps to download the right data for a assumed date and move further. The code has been executed successfully. So it wrote the code, it executed the code, and then terminated after opening that graph that I just showed. So this is how two agents work together in order to get things done for you. The only instruction we gave was this. Look at how much things it did for you, including the first, that is most important, understanding the task and then dividing it into subtasks. All right, coming towards the deck again. There can be other examples. I will not go into that much detail in more complex examples. So there is another group chat example that I have where user gives problem and there is a planning agent that plans for it, then engineer, executor, and critique do their jobs to perform the overall operation. Just quickly seeing this one. So there are multiple agents that we wrote and then initiated a task. This is the primary task. Each agent knows what it is capable of doing, and they will, if I run it, they will interact with each other to get this thing done. So they will look for papers published at a particular source and create table of it and divide them into different domains and work them as critique or planner or scientist or engineer on those research papers. So this was our overview of, like till the last slide, the overview of Autogen. Now, built upon Autogen, Microsoft has recently introduced Magentic One, which is more comprehensive multi-agent framework. And it is an AI-driven multi-agent system designed to autonomously manage and complete complex tasks. It achieves this through a structured two-loop orchestration model, ensuring efficiency, accuracy, adaptability, all of those. So you can see here, let me open highlighter again. So you can see here, this is the overall orchestrator, and there are agents which can do operations, different kind of operations, coding, access computer terminal to get things, web surfer to surf internet and get information, and file surfer to navigate to files. The two loops that I was talking about, you can see that there is one loop that on each iteration it goes closer to the goal it has to achieve. The first thing, it divides the whole task into a ledger of subtasks, and then it measures on each iteration that what part of the operation it has already completed. So is it getting closer to getting overall objective done? So the outer loop, which is called the strategic planning loop, oversees the task ledger, and it includes the facts, educated guesses, and an evolving action plan. So it can, why I'm saying evolving, because sometimes originally what it will plan will not take it closer to the overall objective and it will get stuck somewhere. In that case, it will reiterate, it will rethink, it will evolve the action plan. And this ensures the systems continuously refines its approach to optimal task execution. And then there is another loop that manages the progress ledger, uh, this thing. Uh, when I say progress ledger, it tracks the current progress, task delegation, and agent performance. So this enables real-time adjustments and prevents errors from disrupting workflows. All right, so here is an example of Magentic 1. And let's see a task. The task is here. Sorry, my annotation didn't start. All right, so this is the task, right? The attached image. So it assumes that there is an attachment given to this agent containing a Python script. We are asking the agent to run the Python code. So this Python code is on an image. It's not a text file. And we are asking the agent to run this code against an array of string as an input that is also listed within the image or with the provided input. And output of this script is a URL containing C++ source code. So when it will execute the Python code that is part of an image, it will get a URL, and that URL will give a C++ source code downloaded. We are expecting the multi-agent solution to compile that C++ code, run it, and return the sum of the third and fifth integers from there. So there are multiple integers that this source code, C++ source code will provide, and we are expecting the agent to just pick the third and fifth integers from the output and add them. So here in this example, we have file server that is capable of extracting code from image. We have a coder that is able to analyze, understand, and the extracted Python code from image. We have a computer terminal that is capable of executing the Python script and get the URL that it will return. And we have a web server that is capable of navigating to the URL we got from the Python code and extract the C++ code that we need to run. And then we have another coder. This is C++ coder that analyzes and analyzes the extracted C++ code. And then we have another terminal that compiles and executes C++ code to produce the final result. And when we get the final result, we will have to add that, the third and the fifth outputs. So you can see there were a variety of actions or tasks we wanted done, and we will just assign it to a multi-agent solution built with Magentic 1, and we will get these things done. It's kind of a generalist multi-agent system. Now, when we talk about different agents, why do we need different agents to get things done for you? Why not just one agent can do everything? The reason is that we can have multiple agents relying on different LLMs to get things done for you, or uh, having different expertise to get things done for you. So, and when they work collaboratively, they can build a solution that is built by experts of each field, or which is trained to do specific tasking. If we try to make one agent do everything, might not be as good as a specialized agent in a specific field, or it can be a gigantic operation uh, needing too many resources. So this brings that how different agents are different and how different LLMs are different. So we have an option of fine-tuning LLMs. And fine-tuning is a process that makes them different and specialized in a specific field. So fine-tuning can help in adapting a pre-trained large language model to perform specific tasks more effectively by training in a specialized dataset. This in turn enhances the model's ability to generate accurate, domain-specific, and company-specific responses. So for example, here you can see that before fine-tuning, we asked this LLM a question: why is the sky blue? And a generic answer appeared that because of the way atmosphere scatters sunlight, right? But after fine-tuning on more scientific data or more data that had information about Earth, Earth's atmosphere or physics, cosmos, right? All those things. It can answer more precisely. You can see a detailed answer that the sky appears blue because of the phenomenon called Rayleigh scattering and how it works in details about that. So LLM, a base LLM cannot be expert about everything, but a fine-tuned LLM model can be expert about a specific field. So how we fine-tune, or how fine-tuning actually works. So it starts with a pre-trained LLM, just like ChatGPT or Llama or Claude, and that's what we call foundation model. And then what we do that we train an existing foundation model with specific data. So foundation models are trained on vast general data. They know everything a little bit. But we collect and prepare data on a specific domain, like legal or legal documents or medical or customer interactions on a specific support related issue, or a specific field of study in science. And we collect that data and then train our model or expose the model to new examples while preserving the general knowledge it has. So through the general knowledge, it has the basic information, it understands the language through that, and then we provided specific knowledge about a subject. So we use techniques like learning rate tuning or parameter freezing or reinforcement learning to balance specialization and generalization. And in the end, we test the model against benchmarks to ensure improved accuracy and reliability before integrating it into the business application. This is one way of getting specific fields expert through LLM. Another is a simpler way that is called RAG or retrieval augmented generation. So this is a framework that combines information retrieval with text generation to improve the accuracy and relevance of response. Instead of relying solely on the model's pre-trained knowledge, RAG dynamically retrieves relevant information from external data sources before generating a response. So when we fine-tune, we do it beforehand, not with the query, which it takes more time to prepare a fine-tuned model. We prepare a fine-tuned model with detailed data about a specific subject, and then the model is ready to answer in more detail. But when we use retrieval augmented reality or retrieval augmented generation, what we do, we provide the additional data on which we want to answer the question along with the query. So it is the foundation model at the back. We just provide some external context to foundation model with the query that we are asking right now, and it understands the query better with the information provided with it to summarize the output from the information we just provided with the query. So what we do is that the user has a query, the system receives the question or a prompt, and then there is a retrieval step that it searches for the relevant information from external sources, databases, documents, APIs, knowledge base, whatever we have connected it with, and then injects retrieved data into the model's context, enriching its response with the latest and the most precise information, and then generates a response using both its pre-trained knowledge and its retrieved data. So this is another way of having a specialized agent to work. All right, so here's a difference, like how RAG and fine tuning is different. You can see that RAG has external knowledge that it reads while answering, while fine tuning does not do that. Fine tuning has a model with changed behavior, pre-trained, fine-tuned. RAG relies on the information within itself, provided with the query, so it has less chances of hallucination. Detailed training data is required for fine-tuning, while RAG can work on without pre-training the foundation model. RAG has dynamic data connected real-time coming up with the query, so it can be more precise or more advanced or more accurate if it's changing data, while fine-tuning does not have that ability to work with dynamic data. There are a few more differences here in Autogen and Magentic 1 frameworks. So Magentic 1 and Autogen differ in their approaches to multi-agent collaboration. Autogen focuses on self-improvement and task generation through dynamic learning and adaptation using indirect decision making, while Magentic 1, on the other hand, prioritizes goal alignment, ethics, strategic constraints with direct decision making based on predefined objectives. So Autogen emphasizes on performance optimization. Magentic 1 ensures ethical and strategic alignment with stronger governance. As a result, Magentic 1 is better suited for mission critical, value driven operations, while Autogen excels at autonomous problem solving with task optimization. This is a very interesting Venn diagram. You can see that CrewAI, LangGraph, and Autogen, they each have some traits and some common traits also. So you can see that LangGraph has the ability to work on complex workflows better, um, while Autogen has enterprise teams easier developed to work in collaboration, while CrewAI is good for rapid prototyping. Um, Autogen and CrewAI both are easy to use, while LangGraph is not that easy. LangGraph and CrewAI are a workflow management kind of tools, while Autogen is not that much of workflow management tool, LangGraph and Autogen are advanced error handling capabilities. CrewAI lacks there a little bit, but both all three of them have RAG support, coverage, and human in the loop operations, memory support, and multi-agent support. So, if in order to choose the right multi-agent framework, you can follow this. So, if first, what type of agent you want to develop, like it can be a complex multi-step workflow, a simple sequential task, or collaborative multi-agent task. So let's suppose if you want to have complex multi-step workflow, do you need precise control over the agent's interactions? If you want, go for LangGraph. If you want it more of self-driven, you can go for either CrewAI or Swarm. Swarm is OpenAI's multi-agent framework. If you prefer doing DIY without having experts to involve, go for OpenAI Swarm. That is easier to work with. If you want, if you have some techies working for you, go for CrewAI, though it is also pretty simple. If you have a sequential task, you can, if you want to minimize the framework specific code, go for Swarm. If you have a team of expertise, if you don't want to minimize and you have a team of expertise, experts involved, go for LangGraph. Otherwise, go for CrewAI. So this is how you can decide which multi-agent framework may suit you. So you can work if you have a collaborative multi-agent task, and task assignment is skill-based or workflow-based. You can divide it based on that. If it's skill-based, use CrewAI. If it is workflow-based, you have to decide between LangGraph and Swarm. If you prefer framework features or flexibility, if it's flexibility, go for Swarm. If it's framework features with a structure, go for LangGraph. So here's an agent we developed for a customer, and I can show you what we did for them. A business use case here. So there, for their, they had a B2B customer that ordered something online, and the delivery status on the e-commerce portal was not accurate, and the delivery got delayed. Let's consider this scenario. And B2B customer is not really happy because he's not getting transparent response that through the e-commerce portal that why the delivery is delayed. So he contacts support through any of these channels. Possibility of getting contacted through all these channels was provided, and asks about the particular order he is curious about. The query gets to Copilot agent, and Copilot agent checks Salesforce to see the accurate response about why this delivery is delayed. If Salesforce has the right reply available, some other reason available of the late delivery and a new date of the delivery, the Copilot agent takes that information and provides it back to the customer through the channel he or she contacted with, and updates the e-commerce portal as well. And that somehow satisfies the B2B customer about the delay. But there can be another scenario that even say that Salesforce does not have the right information available. So, and when I say Salesforce, it's a CRM that they are using, not for the e-commerce. So the Copilot checks that this item was originally to be delivered from a Japanese supplier, and we don't have clarity why it got delayed. The Copilot makes first of all checks who the supplier is, and then checks the method of contacting the supplier. There is a possibility of contacting the supplier by multiple methods, even a call it can make. So it can make a call and talk in Japanese or leave messages on the support channel of the supplier in Japanese, asking about the delivery of that specific order. The response it gets is again understood by the Copilot and interpreted back into English and updated into Salesforce, updated into the channel where the customer asked for, updated into the e-commerce portal. That somehow satisfies the customer with the new delivery date. So it's pretty easy to start with a smaller project on such assistants to groom your business to provide better customer satisfaction or employee satisfaction. It's very easy to start with smaller use cases, and you can ultimately achieve much bigger gain out of it. We can take questions here. I don't know if you guys already have typed any. I can check. If you haven't so far, you can type your questions now. All right, I can see a few.
Asif, we have few questions on the chat. I can read the first one.
Okay.
How do you enable guardrails so that the agents don't run malicious code? And I think that continues with the same one. How much efficiency is affected due to local models instead of OpenAI GPT? So maybe you can start with the first one.
All right, it's about the guardrails. So you can specify what the agent's boundaries are. For instance, in one of our agent, we specified that do not compare prices of competitors providing the same services or products. So even if discussion goes into that direction and agent is asked about comparing prices, it will say that it cannot do that. Similarly, you can specify the list of allowed libraries or list of not allowed libraries that the agent cannot use if you're asking about malicious code. So, or you can give it allowed or blocked list of websites that it can go or not go to. So you will have to put those guardrails within your code or within the sources that you provide.
Okay, great. The next question we have is, what governance and compliance related hurdles do you see in implementation of these agents?
All right, so it's a broader question. I can take a few examples, but if you have a specific question about this, you can just refine your question also. So for instance, for one of our customer, their problem was that interacting with these agents, they do not want employees or even customers to provide sensitive information like social security number or credit card information. So what we developed there, or it is a possibility to uh, keep it with Copilot or other agents, that you can specify that it will not accept or use such information, and rather reply with that this is sensitive information you're not supposed to share. Um, uh, Copilot is like capable of um, encrypting documents if they have sensitive information by itself, or totally denying that it cannot accept such information. That's one area of governance or regulatory compliance that you can put in.
Okay. So we have another question. Have agents been used in conjunction with digital twins to create a multifaceted model response, especially in manufacturing operations?
Yes, they can be used, and I think people are using it in this area. So when you have digital twins have APIs available to interact with that. Okay, so let's suppose um, if there is a digital twin to check that if there is a soap dispenser about to get empty in your mall, and that digital twin has some transducers or some sensors providing this information. Uh, you can listen to that, or um, from an agent, and that agent can perform an action on top of it, maybe putting a service request to the maintenance staff to refill that um, dispenser, right? So that service request can be totally into some other system, maybe ServiceNow, while the information that the container is getting empty is received from a digital twin. Similarly, the agent can ask digital twin to take action if, let's suppose, in a retail store, your there are robots running to put items into the shelves. If a particular SKU is getting emptied on a shelf, and you have robots that need to go and put the restock the shelf, um, you can trigger that from an agent based on the input received from maybe some other system,
Okay.
maybe the inventory management system.
Okay. Hope this was answered. We have another one. Do we have the option to integrate custom LLMs like Claude, Gemini, or self-hosted on Llama?
So depends. Like in fact, the short answer is yes. But if you're using um, the framework that I showcased, right? It by default works with OpenAI, ChatGPT. So, but it can work with other LLMs with a little bit of more code. So if I just provide the model name, remember I provided the model name at one screen when I was writing code. I can only provide model names of ChatGPT there, and it can work with that. But in order to do it with some other LLM or my LLM at my own machine, I will have to write some extra lines. It will be a little more complex, but it is possible.
Thank you. There are a few more questions, but we are all out of time. Hopefully, the session was very useful and insightful. Thank you, Asif Hussain, for hosting this session with us. And everybody, please feel free to write back to us if you have any additional questions. You can write it to at info@royalcyber.com, and we will answer those questions individually. And thank you.